Hello everyone, this is Jyoti Katigi from ENC department BGMIT Mudod. Today we're going to see the next experiment on DSP lab, that is autocorrelation of two sequences and verification of their properties. The aim of the experiment is to write the Skylab code to perform the autocorrelation on a given signal and to verify its properties. Next is the theory related to this, that is in signal processing, what the correlation means, or in general what the correlation is. Correlation is a measure of similarity of two waveforms. We need to verify, or we need to find out what is the similarity between the two waveforms as a function of time lag applied to one of them. Then this is the definition for correlation. Then this is also known as sliding dot product or sliding inner product. It is commonly used for searching a long signal for a shorter known feature. Then what is autocorrelation? Autocorrelation is a special form of correlation in which a signal is cross convolved with itself. That means one signal is compared with the same signal, but it is shifted version of that. Okay, it is nothing but the autocorrelation. Okay, in this what happens, in which the signal is cross convolved with itself only. It is a mathematical tool for finding repeating patterns, such as the presence of a periodic signal which has been buried under the noise, or identifying the missing fundamental frequencies in a signal implied by its harmonic frequencies. It is often used in signal processing for analyzing functions or series of values such as time domain signals. That means correlation is the measure of similarity between two waveforms. We are comparing two signals. In that, one signal is the original signal, other signal is a shifted version of that, or other shifted version of other signal. In specific, the autocorrelation is nothing but it is a signal in which the signal is cross convolved with itself. Means one signal we are taking, the same signal we are shifting or folding, we are doing the cross convolution of that. Then we are comparing the original signal with a folded or a cross convolved signal. Okay, from that what you'll get, how much the relation between the two signals. Okay, this is regarding the theory of autocorrelation. Then we'll go to the programming part of this. Here is the program for autocorrelation. Okay, as you are knowing, the three first instructions are CLC, clear, and the close. Next, X is equal to input, enter the input sequence. We'll enter the input sequence values that we are taken as X. Then M is equal to length of X. That means the length of X. What will be the length of X? That will be stored in M. Next, Lx is equal to input, enter the lower index sequence, index of input sequence. That means you already entered the input sequence. You need to mention what is its lower index, means where it will start, whether it will start at 0, input sequence will start at 0, 0th position, or it will start at -1 position. That you need to mention it here. Next is Hx is equal to Lx plus M minus 1. Okay, Hx is Lx, how much you got it? That Lx plus the length of X, that is M minus 1. That will be stored in Hx. Next, N is equal to Lx colon 1 colon Hx. That means N is the length of the It will mention what will be the length of the output sequence, where it will start and where it will end. It will start at Lx and end at Hx. Hx is already you are calculated. Okay, then x fold is equal to x of dollar colon minus 1 colon 1. X fold, what it will do, already you have entered the input sequence, that is x. X fold will do the reverse of x of n, that means you will get x of minus n. Next is nx is equal to lx plus lx, and nh is equal to nx plus m minus 2. Okay, then r is equal to nx colon nh. That means r is the length of the autocorrelated sequence. Means where it will start. It will start at nx and end at nh. Okay, whereas here we have mentioned n value means here the start of where the nx will start, x will start, where the input sequence will start and where it will end. Okay, input sequence starting and ending value n will be, it will stored in n. Then output sequence starting and ending value will be stored in r. Then we have to calculate the autocorrelation of x with x folded sequence. That rxx is equal to convolution of x comma x fold. That means autocorrelation formula is rxx of L is equal to summation n tending to minus infinity to plus infinity x of n into x of n minus L. Okay, this is autocorrelation formula. Here the both the sequences, see, you are comparing the same signal x of n with the folded sequence of x only. Okay, that's why I written here rxx of L. Okay, then summation n is varying. Okay, this is autocorrelation formula. Depending on this only, we have calculated the rxx, that is convolution of x with x folded sequence. As I told, x folded sequence is the reverse of x sequence, that is folded version of x of n. And then after calculating the autocorrelation, we need to display, okay, what are the values you got it, autocorrelation values. Therefore, DISP of rxx comma autocorrelation of rxx of n. It will show the values of rxx. This is about autocorrelation function, autocorrelation of a sequence. Then we need to verify the properties of autocorrelation also. Here we will see the two properties of autocorrelation. The first property is property 1 is equal to, that is autocorrelation of a sequence has even symmetry. Okay, autocorrelation of the property should be even symmetry. What is even symmetry? That is rxx of n should be equal to rxx of minus n. Okay, this is the property. If this holds good, then the autocorrelation of a sequence has even symmetry. That means already you have calculated rxx of n. You need to calculate rxx of minus n. If both these two are equal, then it is a even symmetry. Okay, now we will calculate the rxx of minus n. Rxx of flip. Okay, flip means folded sequence. Rxx of flip is equal to rxx of dollar minus 1 colon 1. That means rxx will be folded. Rxx, if rxx of n is folded means you'll get rxx of minus n. That will be stored, assigned as a variable rxx of flip. Then if rxx of flip is equal to rxx, okay, if the folded sequence is equal to rxxx, original autocorrelated signal, then we need to display property 1, that is autocorrelation has a even symmetry. Then also we have to display what is the flipped version of RXX. That is autocorrelation of time reverse sequence. That is RXX of minus n. That values also we need to display. Then this is the end of first property. We are verifying here whether the autocorrelation is even symmetry or not. That means whether Rxx of n is equal to Rxx of minus n or not. That we are verifying. If both these two are equal, then it is a even symmetry. Okay, that is the property. Always the autocorrelation should be an even symmetry. It should not be odd symmetry. Next, second property is property 2, center value of Rxx of 0. Center value is Rxx of 0. That should be equal to total power of the sequence. Okay, you need to calculate. You already calculated the Rxx values. Here you have calculated Rxx values. What they are saying, the center value of Rxx. Okay, that is Rxx of 0. If this Rxx center value of Rxx of 0 is equal to total power of the sequence, then the autocorrelation property holds good if these two both are equal. For that we need to calculate the power, the total power of the given sequence as x of n. Okay, suppose your x of n value is 2, minus 1, 3, 4, 1 is there. This is the x of n value. How to calculate the power of this? Okay, magnitude of x of n whole square. Okay, summation of magnitude of x of n whole square. For each value of n, you need to calculate the square value. You have to square that, then you have to add all the squared values. You get a power for that. Okay, for that here x of n will be what? You have to take the magnitude of 2 is first sample you have to take. 2 is magnitude of 2 is 2 only. You have to square it. You get 4. Similarly, you have to do minus 1. Take the magnitude first. Magnitude of minus 1 is 1. Then square it. You'll get 1. Similarly, you have to do other values also. 9 plus 16 plus 1. How much you got it? 31. The power is 31. Total power of the given sequence is 31. That's why you are done TOT underscore PX. That is total power is equal to sum of X power 2. Okay, sum means summation. Sum of X power 2 we are done. You have calculated the total power. Then you need to compare this with center value of Rxx of 0. For that we have calculated here mid is equal to CEIL of length of Rxx by 2. Length of Rxx, whatever the length of Rxx you got it. Okay, Rxx already you have calculated. Okay, length of that you have to calculate. That length of Rxx divided by 2 you have to do. Suppose you will get length of Rxx by 2, you will get it as 4.5. Okay, if we'll get 4.5, CEIL what it will do? It will round off its value to higher digit, 5. It will make CEIL will do the round off its value to the higher digit. 4.5 length of Rxx divided by 2. If you got it as 4.5, then CEIL will do it round off its value to higher digit. Okay, next is if total power TOT underscore PX is equal to Rxx of mid. Okay, total power if it is equal to Rxx of mid value, how much you got it? 5. Midpoint of Rxx of. If these two values are satisfied, then display the second property. That is center value or maximum value is equal to total power of input sequence. Total power of input sequence should be equal to maximum value of the Rxx or the midpoint value of Rxx RXS you got it. What is its midpoint value? Okay, that should be the maximum value, and that also should be its midpoint. Okay, maximum value will come under the midpoint. The midpoint value, whatever you got it, if that is equal to total power of the input sequence, then the second property is verified. Okay, here I verified the second property, end of this. Okay, here I have verified the two properties. First property is you are verifying whether it is even symmetry or not, whether autocorrelation is a even symmetry or not. The second property you are verifying whether the total power of the given sequence is equal to midpoint of Rxx value or the maximum value of the Rxx value. Next, we need to display whatever value you have calculated, we need to display in the graph. That's why what I have done here, subplot 2 comma 1 comma 1, two graphs will be coming, two rows and one column. First figure indicates the input sequence values and the second figure indicates the output frequency values Rxx. Okay, now I'll execute this program and we'll see what we'll get, the output waveforms. See here, enter the input sequence. I'll enter as 2 minus 1, 3 comma 4 comma 1. Any value you can enter. Input sequence I have taken this. Next, enter the lower index of the input sequence. That means where the x of n will start. Suppose I'll take x of n will start at -2 position. Enter. Now you see the autocorrelation value Rxx of n is 2, 7, 5, 11, 31, 11, 5, 7, 2. Okay, then its property is also verified. Autocorrelation as a even symmetry. That means if we'll reverse this Rxx value, you'll get again the reverse. After doing the reversal, you'll get same values. Flip flop of that. Okay, that's same. See, these two are values are same. Rxx of n is equal to Rxx of minus n. Therefore, it is a even symmetry. Similarly, the total power, how much you got it? The total power value got it as 31. Previously I solved this, 31 you got it. Total power of x of n you got it as 31. Okay, that is what here, it's the midpoint value or it's the maximum value. Maximum and midpoint values are same. Therefore, now the total power is equal to the center value or the maximum value. Therefore, the second property also holds good. Then the graphs for the input and the output sequences. I'll show the graph for this. Okay, this is the graph for the sequence. This graph is for the input. What you have taken input as 2. At -2, it will start at -2 because the lowest index you are given as -2. -2, the amplitude is 2. At -1, amplitude you are taken as -1, 2 minus 1, 3, 4, 1. Okay, -1, its amplitude is -1. 0th axis is here. It is coming down means its amplitude at -1 is -1. Then 0, starting position is 0, ending value is 3. At 0th position, the amplitude is 3, 1, 4, then 2, it is 1. This is input sequence. Then this is output sequence, autocorrelated sequence, that is Rxx. Okay, what are the values you got it there? The same values will be plotted here. Okay, this is the autocorrelation of the given sequence. See here what are the values you got it in the previous window, output window. You got these values 2, 7, 5, 11, 31. Okay, the same value will be displayed in the graph. Okay, 2, 7, 5, 11. This is 31. Okay, therefore this is the autocorrelation. Now in this program what we have done, we have calculated the autocorrelation of the sequence, and then we have verified the two properties of autocorrelation. Thank you.